Hi there, my name is Jessy Mrozowski, and I'm a computer science student from Sturgeon Heights Collegiate. This video is from our Computer Science IB Higher Level Internal Assessment. After discussing with the client what kind of features he'd like develop into the game, well, first of all, the type of game he wanted developed is called a bullet hell, and he wanted it to closely resemble other bullet hells that are Japanese style. These include features of focus, the type of behavior that the ship does within a game of a bullet hell, and that the player's ship progressively gets stronger. He insisted that he wanted 3D sound effects incorporated into the game, as this was going to be a 3D bullet hell, and it is. So I've incorporated 3D sound effects. It's best experience with headphones, it's quite beautiful. The game that is able to pause, and that it had an ambient background music that you could either stop or adjust the volumes of. That the player's ship had simple controls for example, WASD or the arrow keys for movement, and that it featured hardware acceleration. This is one of the main things that he wanted into the game, as in a 3D environment, sometimes rendering can get a little costly. So using the GPU really helps improve the performance of the game. We'll dive into some code right away. This is the game engine class, and it holds the game loop, bread and butter of the game. This is a kind of unique game loop, as you can see, as it takes into account not delta time, but a base delta time that it tries to run at each time. Essentially, this game loop runs at approximately 60 updates per second, as you can see up here. And if an update takes more than this amount of time, then it'll skip a render call. This is why we see the skip frames and max skip frames, because each time we skip a frame, it'll count up. And then if we skip too many frames, it'll force a render actually. This way that the player isn't forced to play without a render for who knows how long and just staring at a blank screen as the game updates indefinitely. But yeah, updates don't usually take that long to process through, as I've tried to make them as efficient as possible. And if the game actually starts to run too fast and it updates too quick and it renders too quick, then the thread will go to sleep for it'll go to sleep until it estimates when its next update or render call will be. So it keeps the game running relatively, actually super smooth, and the game runs at 60 frames per second, and it's very nice. This is the camera controller class. This basically controls the camera that is behind the player ship. Because it is a 3D environment, it's very important that perspective is well controlled and that the player feels like he has a very good sense of perception of where the ship is and where everything else is. So this camera controller class basically controls the position and the rotations of the camera on each axis, which is X, Y, and Z. The camera controller class also has an aspect ratio for the camera. Its max view distance and its closest view distance. And then it also has some other stuff like mouse sensitivity, max lookup, and max look down. This would be used if I were to create a first-person shooter game or something, but we didn't need it, thankfully. The object loader class, this is where I load in all the 3D models that are used in the game, which is the player ship and the enemy ship. It reads from it parses an object file, and every object file has specific strings in front of it to determine what that line is. So it's pretty easy to break down. Just read the first string and then assort it into whatever it needs to go into. And after it's loaded, I create a static vertex buffer object with the parsed OBJ file. The OBJ file, by the way, gets stored in a class called a model, and then that model class is read from, and then it creates float buffers out of the vertices and the normals of the model class, and it stores them into buffer objects, which are then handed back to the model handler class, which is over here. And that model handler class holds all the models that are used in the game, and then it passes the references of the IDs of the vector buffer objects to the player class, which then renders the player ship. In the player class, I'll show you a little bit about how the vector buffer objects are rendered. This would be an example of like the hardware acceleration that's used. First of all, we just bind both the buffers. That we bind them to pointers so that when we call draw, and it knows how many values to read from at a time when placing a point to connect lines to. So an example of that would be like we have x, y, and z. So the vertex pointer is 3 values, x, y, and z, and then it would place it in the world, and then it knows that that's one point that we need to draw, and then it'll connect it to another point, which would be the next 3 values of the x, y, z, and so forth. Something we need to do with rendering in OpenGL, and especially if we want to use hardware acceleration, is that we need to enable client states. This basically prepares the GPU to render, as the vector buffer objects are stored in graphics memory. So we enable the 2 client states, vertex and normal. We draw the array or the vector buffer object, and then we disable the client state, because if we were to leave it open and say we wanted to render a 2D object after, we would run into many errors, as it would try to render from the GPU, but it's supposed to be a CPU rendered call, and everything would crash. The hitboxes for the player are dynamic, so what I mean by that is if the player ship rolls, as it rolls on the z-axis, then the hitboxes will move up and down depending on how the player ship is orientated. And that's a little bit about how hardware acceleration is used. It's also used with something called a shader, and if we look on the side here and here, we can see that I have 2 different types of shader used, a per pixel fragment shader and per pixel vertex shader. This handles the vertices of the lighting, and this handles how the lighting looks, like its color and what kind of values it has, the shininess, all the little details. In my OpenGL class is where I try to handle where most of OpenGL is initialized. Here we have just some basic stuff being initialized and used in OpenGL. This is where if I want to switch between a 3D render and a 2D render, I have to change. First of all, in a 3D render, we want to render from the player's perspective. So we apply a perspective matrix, which is like field of view and some camera effects, whatever you want added, and then this is like the position of the camera. And then for 2D, we have to reset the projection and the view so that it projects from this corner of the screen to this corner, and that everything is drawn on Cartesian plane. And yep, some basic, well, I won't go into too much detail about it, but we'll move on to the sound handler class. This is where I handle where all the sounds happen. And again, this would be an example of how buffer objects are used, which is part of hardware acceleration. First of all the music files, they're all WAV files. Some are mono WAV files and others are stereo. The stereo WAV files are the ambient background music, and the mono files are like the player shooting his laser or getting hit. And the reason they're mono is because when I incorporated 3D into game, you can't have a stereo sound playing from a 3D space. That's just how OpenAL works. I couldn't go into detail about it, but mono sounds are needed for 3D environments, and they sound absolutely amazing either way. So they get stored into a buffer, and then once we don't need the WAV file anymore, we dispose it. This is to save memory and to clean up a bit. We store the buffers into a source. The source basically handles where the sounds will be played on the system, on the computer system. So if I didn't want sounds to overlap, or if I wanted sounds to overlap, I would have multiple sources. This way I could have many different sounds playing at once, but that wasn't a main concern in the game, as I'm not having like 20 different sounds playing, so I have everything in one source and it's all binded together and everything. Here's we add the buffers into the source, for example the music, stereo, loops, and then this is like the player shooting and player getting hit. And then I think I'll dive into some gameplay now so I can show you exactly how everything works out. By the way, the gameplay is best experienced with headphones, so you can hear the 3D sound effects of the game, so I recommend putting headphones on if you have any. And this is just a little loading screen I made to have some visual appeal for the player while they're waiting for the game to load up. And we'll start some gameplay right now. Again, this game is best experienced with headphones, so I can demonstrate the 3D sound effects, but at the start of the game, some basic instructions: movement, WASD or the arrow keys, shift is focus, which is this. I tried to make the camera transition as smooth as possible. C was shoot. Then there's some basic instructions, and music will start very shortly. And I'm going to pause it once it does start. And to pause the music, if we look at the top left corner, I have a music on off, which is the 0 key, and we can also adjust the volume of it, which I'll show you when it starts. So yeah, that's how we can pause and start the music. Starts where it's left off. We can also pause the game. As you see in the top left corner, there is a pause function. It just stops the rendering, it stops the updates, and I still have keyboard controls and mouse updates happening, but that doesn't affect the actual logic of the game, so save from that. If we look in the bottom left corner, I have a shield. The shield is used to determine how close the player is to dying, because the game does get a little hectic, so I didn't want you to die on your first hit. The shield gradually goes down when you get hit, and it also regenerates if you haven't been hit for a while. At the top we have the enemy HP. Each time it goes down a couple, like 1,000 or something, it changes color. When it does change color, the boss does get more difficult. There's lives in the top left right corner, and at the bottom is experience. Once you reach 100 experience, your ship moves faster, and you also have increased firepower, just more bullets. And then the level is the level of ship yours right now, and mine's at 0. And I'll just demonstrate a bit. But the shield, each time the player gets hit, there's a little indication of it, a little white flash. It is in 3D sound effects, so if I move from there, you can hear it from the left. Here, you can hear it from the right. If I shoot and move right, up, center, down, and left, the 3D is pretty much on point, and it's very fun to listen to. The way the hitboxes work, I will show you when I run the game again, and I'll enable hitboxes just to give you a visual representation of what they look like. But as you can see, enemy health does go down when I hit it. When I focus in, the shot pattern changes a little bit. You also get that new perspective and a lot slower movement speed. The play area is limited. I would have added a visual of it, but I didn't think it was needed. So yeah, here's just some of the patterns that the ship does, that boss does, I mean. And now that I'm level 1, I've increased movement speed. It makes it a little easier to avoid these. And I also have increased firepower. As you notice, I'm shooting more additional bullets now. And I'll quickly show you the death animation. I become invulnerable for a couple seconds when I respawn. This is to allow the player to adjust and move into position to avoid bullets, and then invulnerability is disabled and I can get hit again. As you see, the lives have went down. Oh, and every time you get hit, you lose 1 experience. So you're rewarded for not being hit and also punished for being hit by the bullets. And I'll restart the game and demonstrate how the hitboxes work. So here's the game with the hitboxes. As you can see, as I was talking about earlier, the hitboxes are dynamic. They move with the ship up and down. The hitboxes on the enemy ship are very large, as it is actually a very large model. And again, the game runs at 60 frames per second when I don't have any recording software, and it's very smooth and appealing to watch. But yeah, I was just demonstrating how the hitboxes are managed in this game. They're placed a little bit in front of the player ship, and then same with the enemy ship. They're placed just a little bit in front of it, and as soon as the bullet spheres intersect with the other spheres, it registers as a hit, which I should have shown, well, I could have shown you in my game optics class. But basically it's a sphere-to-sphere collision, and it uses some basic trigonometry to calculate it. And it returns a boolean of true or false if they've collided. So that's been my computer science IB higher level final project. I hope you've enjoyed it, and feel free to play it once I include the project folders, and you'd have to properly set up the libraries, but I hope you've enjoyed my game, and I look forward to developing more eventually.